Hi everyone, in today's lesson we're going to talk more about related rates. Today we're going to focus primarily on a volume of a cone formula. So let's look at example number 1. It says a conical water tank has a radius of 3 meters and a height of 6. Water is flowing into the tank at a rate of 12 cubic meters per minute. How fast is the water level rising when the water is 2 meters high? Leave your answer in terms of pi if applicable. Okay, so let's first draw a picture. It says a conical water tank. So I'm going to assume it's an inverted cone, so the cone is upside down. So I'm going to draw a cone like such. And I'm going to label the information that they tell us in the beginning. They tell us that it has a radius of 3 and a height of 6. So radius, remember, is half of the circle. So radius of 3 and a height of 6. Okay, let's keep reading. Then it says water is flowing into the tank at a rate of 12 cubic meters per minute. We know the word rate means derivative, and we know cubic meters is x to the third, or when we use that, it's for volume. If it was squared, meters squared per minute, that would be area. So I know that it's volume and it's a rate, so it's a derivative. So water is flowing into the tank, so dV dt, at a rate of 12 cubic meters per minute. Now they want to know how fast, so that's another rate. So how fast is the water level rising when the water is 2 meters high? So let's talk about that first part. How fast is the water level rising? So water level is how, like, think of the water coming in and going up, 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 up. Water level is my height. So how fast is another rate. So dH dt. How fast is the height changing with respect to time? So how fast is my dH dt, water level rising, when the water is exactly 2 meters high? So at the specific time when my height is 2 meters. Okay, so in order to answer this question, we're actually going to have to take the derivative of this volume formula. And if you notice, dV dt is given to you as 12, so that's my hint that I'm going to have to take the derivative of this formula. However, all of the formulas that I've given you so far have only had one variable. Do you see here how there's a r and an h? Technically, if you wanted to rewrite this formula, you could write it as 1/3 pi r squared times h. So technically, if I wanted to take the derivative, this would be our first and this would be our second. So we would technically need a product rule. But there is a way around the product rule if we follow these first 3 steps. So step 1, we're going to use the initial condition. So use initial condition to write r in terms of h. And what this is going to do is give us that one variable. So what do I mean by initial condition? They tell you that the water tank has a radius of 3 and a height of 6. That is your initial condition, 3 and 6. So the way that we are going to do this is very simple. We're going to set up a proportion where 3 is your radius and 6 is your height. Now you could have done 6 over 3. I'm just choosing to do 3 over 6. So we're setting up a proportion with 3 is to 6 as your r, radius, is to your height, right? Because 3 is my radius, 6 is my height. And we're going to cross multiply this. So 6 times r is 6r, and 3 times h is 3h. And we're going to divide by 6. So r is equal to 3h over 6, which we know is 1/2 h. And it would be in your best interest to write it as 1/2 h rather than h over 2. And you'll see why in a second. So now, once we've done that, step 2, we're going to rewrite our volume formula with one variable. By simply plugging in this value that we got for r. So I'm going to just start by writing this volume formula down. So volume equals 1/3 pi r squared h. And everywhere I see an r, I'm simply going to plug in 1/2 h. So I'm putting it in right there. So 1/3 pi 1/2 h squared, right, radius squared, times height. Now we're going to simplify this a little bit. So v equals 1/3 pi. Now to square this, we're going to square every single piece inside. We're going to square the 1, the h, and the 2. So 1 squared is 1, 2 squared is 4, and then h squared. And then we're going to multiply it by this other h. So remember, to simplify more, multiplying fractions, tops with tops, bottoms with bottoms. So the 1 times 1 is 1, 3 times 4 is 12. Tack on the pi. And then we have h squared times h, or h to the first, keep the base, and add the powers. So now we have a volume formula that has one variable instead of 2. So then step 3 is to take the derivative. And then solve. Solve whatever it needs. So I'm just going to rewrite the formula so I have it again. So volume equals 1/12 pi h cubed. So we're taking the derivative of each side. So dv dt is the derivative of volume. And then when I take the derivative of 1/12 pi h to the third, it's literally the same thing. I'm just going to do this on the side. If I want to take the derivative of 5h to the third, you would take the 3, multiply it by 5, you get 15, keep the base, and decrease the power by 1. So you're going to do the same thing. Take the 3, multiply it by 1/12, so you'd get 3/12 pi, keep the base, decrease the power by 1. And we call this dh dt, since we took the derivative of h with respect to time. Now before I plug in, I'm going to simplify a little bit. So 3/12 I know can reduce to 1/4 pi h squared dh dt. So let's go back up, since we've taken our derivative, and plug in what we know. We know dv dt is 12, and we know h is 2. So let's do that. So dv dt we know is 12, and we know that our h is 2. And we want to find dh dt. So what we're going to do now is just simplify this. So we have 12 equals, now this is helpful here, 2 squared is 4, divided by this 4, right? Because technically you could put this over 1. So we have 2 squared, which is 4, which will cancel out with this 4. So this and this cancel. We're just left with pi and dh dt. And to get dh dt by itself, we simply divide both sides by pi. So dh dt is equal to 12 over pi. Now remember, we found the rate at which the height of the water is increasing. So we need units. So if we go back up to the top, we're talking about meters per minute. So we'll just make sure we go back at the end and we say that our final answer is 12 over pi meters per minute. And that is my dh dt. Okay, so that's it for cones. I would love for you guys to try example number 2 the exact same way that we did example number 1. Follow those 3 basic steps. Do this one completely for homework. And leave your answer in terms of pi, same way that we did before. This is a no calculator, so make sure you're not using the calculator. Do it by hand, just like I did the first one. And we'll start class by going over problem number 2 in the beginning. Okay, thank you so much. Have a good night.